10.2 is on arcs and chords. So a central angle, think about what that word means. So central and angle, so it's an angle that's in the center of a circle. So an angle whose vertex is the center of the circle. So a central angle, this would be a central angle. Angle APB, drawn here. Angle APB. A major arc and a minor arc, which one do you think is bigger, major or minor? Major, right? It makes sense. The word major makes you think of something bigger than minor, right? So a major arc is part of a circle that measures between 180 degrees and 360. And a minor arc is part of a circle that measures less than 180 degrees. So then what's perfectly 180 degrees? That would be half the circle. So it's a semicircle. So a semicircle is an arc whose endpoints are the diameters of a circle. So it's 180 degrees. So for minor arcs, so an example of a minor arc would be from here to here. Arcs are these like lengths along the side of the edge of the circle. Not lengths necessarily, but angles along here. So from here over to here, that would be a minor arc. So we name it just using two letters. So I just say AB. So we name the arcs using their endpoints. So for example, in the above diagram, the minor arc is AB. And if you think about how we first learned like segments, lines, and so on, like a line, we drew a line with arrows on the end of it. A segment, we just drew a little segment, right? So an arc, what we're going to do is we're going to do a little curvy thing. So that's arc AB. So major arcs and semicircles are named not only by their endpoints and a point in between. And the reason we have to name major arcs like that is because if I talk about arc AB, what is arc AB? Well, it's the red thing that I drew in, right? Does that make sense? So if I want to talk about going in the other direction, I can't call it AB because that's already been named. That's the minor arc. So if I want to talk about this other side, the left side, how would I name it? Nope. So if I want to talk about this left-hand side, I can't call it BA or AB. Those are still the same thing. Like AB is the same as BA. Those are the same. What would I call it? BCA, right? I could call it BCA or ACB. It doesn't matter. So ACB. So I have to put a point in between to indicate that it's a longer one. So we have to do that for a semicircle, so we know what direction we're talking about with a semicircle, and major arcs. So the measure of a minor arc is the measure of its central angle. So if I had 50 degrees in here, well, that looks like more than 50. Let's say 100 degrees. Looks like more than 90 degrees. Then this is also 100 degrees. And the measure of the major arc is the difference between 360 and the measure of its associated minor. So if I have 100 degrees for my red curve, what's the blue curve on the other side? 260. Does that make sense? It's the rest of the circle. Okay, so it says find the measure of each arc of circle A. So CD, what do we think CD is? Yep, exactly. It's the same as its central angle, so it's 148 degrees. What about CDB? Well, what about going from here around to B? How much is that, the black part? 180, right? So the central angle in here is 180. So how do I get CDB? Yeah, I have to do 180 plus 148. So what do I get when I do that? 230. 328, is that right? What about BCD? Nope, I didn't say BC, I just said BCD. 180, right, perfect. And then if I said BC, yeah, it would be 32, exactly, good. So if you remember, we've talked about segment addition postulate, angle addition postulate. Well, we also have the arc addition postulate, right? So it says the measure of an arc formed by two adjacent arcs. This is some of the measures of the two arcs. So if I talked about the measure, well, I don't know if I want to do m's in front of it. Really, I should do m's in front of it. But so if I have the measure of AC added to the measure of CB, it's going to be the measure of ACB, the whole thing. Really, these should have m's when I talk about their measures, but. All right, so find the measure of each arc. So if I have ST, what do I think ST is? 72, right? TP. What would I add together to find TP? 43 and 65, so I get 108. And then PTR, $270, because I would have to take 360 minus 90. Does that make sense? I have to get rid of that 90 degrees. Do you guys see how that works? Like instead of adding 65, 43, 72, and 90, it'd be much easier to take 360 minus 90. Okay, congruent arcs are two arcs of the same circle or congruent circles. Okay, so you have to be kind of careful with congruent arcs because you can have arcs that have the same like measurement, same angle. So look at this picture. Like maybe these both have 100 degrees as their central angle. So CD is 100 and AB is also 100 degrees. But are those the same lengths? No, one's definitely bigger than the other, right? So these would not be congruent arcs. These would just have the same measure, but they wouldn't be congruent. All right, so theorems about chords of circles. So it says in the same circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if I have that these two chords are the same length, imagine taking your patty paper, I won't make you draw circles on patty paper, and folding it over on itself. So if I fold those two red lines on top of each other, is everybody looking up here? If I fold those two red lines on top of each other, what do you think has to be true about this piece and this piece? They have to be the same, right? So these two arcs would be the same measurement and the same length, really, too. So if a diameter of a circle is perpendicular to a chord, so if I have this chord, again, imagine your patty paper, and I fold the patty paper over on that red line, do you guys see what would have to be congruent to each other? D, E, and E, F. Does that make sense? The two pieces of the blue, they'd have to match up with each other. So with circles, it's really good to think about that patty paper stuff. So folding things over, how do things match up? And then the same idea here, if we have that these two pieces are the same, so if these, whoops, come off a little bit. If this and this are the same, well, that means that these two pieces are the same, and it means that the chord is the same, or the chord is a diameter. It goes through the center of the circle then. It has to create that fold line, that perfect fold line. Okay, do those kind of make sense? Okay, I'm not going to ask you to like perfectly state those theorems, but if you see something, you should know when to set things equal to each other. So like this example. So do you see how we have these two sides congruent to each other? Well, that makes this chord and this chord the same distance. So we'd say, oh, well, 3x plus 11 has to equal 2x plus 48. So we'd set those two equal to each other. So we'd get x is equal to 37. So it says find the measure of arc DB. So I found 37, so go back and plug in 37. So we have 3 times 37 added to 11, so it looks like 122. Do you guys see how I got that? So I just plugged it back in. Are you with me? All right, so find measure of QR. So measure of QR to the nearest tenth. So again, we would set these two equal to each other, and then we would go in and plug in. Do we understand that? Can I skip that? All right, so let's look at the theorem. So it says in the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So imagine our patty paper again. And if I fold these two pieces on top of each other, these two pieces have to be the same. Okay, so those chords are going to be congruent. So imagine pulling the reds on top of each other. Well, then that makes the blue the same, if and only if they're equidistant from the center. So if you see something that says, oh, we have congruent chords here, these are the same, then that means that these two things are the same as well. So it says AD is equal to 40, so it means I have 20 and 20. CD is equal to 25. Find CG. So if I want to find CG, I could really just find FC. So how do I find FC? Let's Pythagorean theorem, right? So I'm going to do FC. Let's call that x. So I'm going to do x squared plus 20 squared equals 25 squared. That's a 3, 4, 5 right triangle. Can you guys figure out what the missing thing is? It's 4 times 5, 5 times 5, 3 times 5. Yep, 15. Perfect. Okay, so that was also x over there. All right, is this making sense so far? Do you guys feel pretty good with this? Okay. So AB is 16, DE is also 16, and CD is 10. Find CF. So be careful. This is 10, but this other one, CF, is not 10. Do you guys see how it doesn't go all the way to the edge of the circle? Okay. So sometimes what we need to do is we need to find other radii to draw in. So this is a little trick with circles. You'll see this a lot. So what we do is we're going to draw this radius over here so that we can find CF. Now what about FB? What's FB? If AB was all 16, it's 8. Perfect. So we're going to have 8 and 10. So if I want to find x there, what would it be? X squared plus 8 squared equals 10 squared. This is also a 3, 4, 5. So it's 6. It's 6, 8, 10. Perfect. Are you guys starting to see those 3, 4, 5s more often? Us geometry teachers, we're not very creative. We use 3, 4, 5s and 5, 12, 13s a lot. We like to have nice numbers. I don't know. All right, so find the length of a chord of a circle if its radius is 8, and if the chord is a distance of 5 units from the center of the circle. So it's 5 there. So we're going to have a little 90 degrees there. And we have to think about how to swing the radius around. So this is used a lot. Sarkis, you with me? So how am I going to swing this radius around so I can use it? So I got to swing this 8. I'm going to put it right there. Do you guys see how that's useful to us? It creates a triangle. Then that allows us to find this x value down here. So we're going to say x squared plus 5 squared equals 8 squared. So we're going to say x squared plus 25 equals 64. What do I get there when I subtract it out? I'm like drawing a blank. 49? No. 39? So x equals the square root of 39? Yeah, not 3 root 13, because we don't have, like, 9 doesn't go into it. That would give us the 3. 6 point what? Okay, so we'll do that. So if I'm trying to find the length of the entire chord, this whole chord here, I would just double it, right? I'd say 2 root 39, or 12.48. So I would just double it out.